So we've been using Pythagorean theorem a lot to find missing sides. Today we're going to be combining Pythagorean theorem and what we call the midpoint to find missing sides. So there's going to be an extra step in here. So the first thing we want to do is define what the midpoint is. The midpoint is the point that divides the line segment into two what segments? No? Any ideas? If it's in the middle, it divides it into two equal segments. You said congruent? That's pretty good. Two equal segments or congruent, same thing. Okay? So, for example, we have this segment right here, MP. That's the length of the whole thing, MP. N is the midpoint of segment MP. The length of MP is 12. So what I want to do right now is I'm going to label the whole thing 12. MP, the whole thing, measures 12 inches. Oh, inches. So let's write inches. Okay. If N is the midpoint of MP, and MP is 12 inches, what is the length of MN? 6 what? 6 inches. How'd you know? Because it's exactly half of the whole thing, which is 12. So what is the length of NP? It's also 6 inches. So let's label those. I like to label the lengths on the segment as well, because for me it helps me to see it a little bit better. But basically the midpoint just kind of cuts the segment into half. Okay? So how does this define or have to do with triangles? Example 2. It works on triangles too. OMG, right? So cool. Your mind is blown, isn't it? Okay. In the figure, P is the midpoint of CB, so segment CB, P right here is the midpoint of that. And AP is perpendicular to CB. So the segment AP is perpendicular to CB, which means that they form what kind of angle? Right. A right angle, and it's already drawn in for you, okay? So basically, AP and CB form a right angle. P is the midpoint of CB, and CB measures 8 inches. So, what is the length of PB? 4. Because P is the midpoint, right? So the length of PB is 4. We don't know if it's inches or centimeters, so we're just going to leave it as 4. So now, I want to know, what is the length of AP, this line? Jacob? 9? How'd you get 9? You're going to use Pythagorean theorem. Let's use Pythagorean theorem. What do you want to call AP? How about X? Okay, what is the Pythagorean theorem? Who remembers it and can tell me right now? Raise your hand. Julian, because you look so excited to say it. Everybody give him a round of applause. Okay. Okay. Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. Okay, so for this triangle APB, somebody raise their hand and give me a leg. X. But you didn't raise your hand. So x squared plus, what's the other leg? Genevieve? 4. The other leg is 4. X and 4 are our legs, so plus 4 squared equals. Who can raise their hand and tell me what is the hypotenuse? Marco. 5. The hypotenuse is 5, so equals 5 squared. This looks like something we can do. What is my first step? Somebody who has not volunteered yet. Jaime. Do what? Square them. Do the exponents, right? So x squared plus, what is the 14 squared? Or not 14, 4 squared. 16. equals 5 squared? 25. Okay, I'm going to move it up a little bit. Okay, who can raise their hand now and tell me what's my next step? Anthony. Good, subtract 16 from both sides. So that is going to give me x squared equals what? 25 minus 16 is? 9. Okay, am I done? No. Who says yes? No, I'm not. What do I have to do? Heather? Take the square root. So we take the square root of both sides. Everybody, what is the square root of x squared? X. Equals, Paola, what's the square root of 9? 3. Okay, example 3, word problem. The figure below represents a map showing locations of Melody's house, Joan's house, and the library. What is the distance from Melanie's house, that's right here, to the library? What should we draw for a library? About just a box with a flag. And a window. And a window. No door? Okay. Her house is teeny too. Let's fix that. Okay. So, I want to know the distance from Melanie's house to the library. What do you think I'm going to use to find that? Who can raise their hand? Noah, will you say it louder? Good, the Pythagorean theorem. So will somebody raise their hand and give me a leg, please, that has not volunteered? Listen. 12 is a leg, good. So that is 12 squared. Plus, what's the other leg? Alana. 5. So plus 5 squared equals, what is the hypotenuse? X. So equals x squared. Okay, ladies and gentlemen, what is 12 squared? Who has that memorized by now? Good. What's 13 squared, just off the top of your head? Good job. Plus, what's 5 squared? 25. Okay. What is my next step, Maria? Add. So 144 plus 25 gives me 169 equals x squared. Okay, what do I do next? Jerry. Take the square root. Everybody should know this by now. What is the square root of x squared? X. You guys need to listen to what I'm asking. What's the square root of 169? 13. So, guys, so the distance from Melanie's house to the library is 13 what? Miles. A 13-foot ladder is leaned from the top of a building to the ground. So here's the ladder. It's 13 feet. Yeah. The ladder is put on the ground 8 feet from the base of the building. So this is 8 feet. This is 13 feet. Okay. Use the Pythagorean theorem, or I guess this one would be 13 feet, huh? And this one would be 8. Use the Pythagorean theorem to find the height of the building to the nearest integer. So we are also rounding, correct? Correct. Okay. What I want you to do right now is set it up by yourself. How do you need me to set up? I want somebody that hasn't volunteered yet. Matthew. X squared plus 8 squared equals 13 squared? Is that what everybody got? Okay. Did you put, if you put 8 squared plus x squared, it's the same thing. Okay, so what is the next step? Trustin. Do the squares. So that's x squared plus, what's 8 squared? 64 equals 169. Now what? Subtract. So x squared equals 105. And then what? Take the square root. Square root of x squared, everybody. X equals square root of 105. Now we have to pull out our number line, right? Okay, so pull out your number line. What is the square root of 105 really close to? The square root of 100, which is about equal to? 10. So our building is about equal to 10 what? Feet. The height of the building.